the back side of your notes, we'll start. Yesterday we did, if you have two powers that are being divided with the same base, we could apply the shortcut where we take the exponent that's on the top, subtract the exponent on the bottom, and apply that to the base. Today it's going to be, if we have a division problem that they are not necessarily powers, but can be, but that division or that fraction will be taken to a power. So what are we going to do when that's the case? Well, let's do some exploring again of what actually is going on. When we have 1/2 to the 4th power, we know that means 1/2 times 1/2 times 1/2 times 1/2. And that is a multiplication of fractions. We can't do any simplifying before we multiply, so we will just multiply across. We have 1 being multiplied by itself 4 times, which is 1. We have 2 being multiplied by itself 4 times, which is 2 times 2, 4, times 2, 8, times 2, 16. Okay, let's look at F. We have -2/x is our fraction, our division problem. It's being taken to the 3rd power. So we know that means -2/x times -2/x times -2/x. Or in other words, we have -2 getting multiplied by itself 3 times, and we have x being multiplied by itself 3 times. So we have, remember when we have a negative number to a power, it must go in parentheses. So -2 times itself is +4, times itself again is -8. And x to the 3rd power, we would leave as x to the 3rd power. And we know that we can clean that up and bring the negative sign out front and have it negative, the fraction negative, and 8/x to the 3rd power. Okay, let's move on to G. Here we have a power being divided by a power, and then that division problem being taken to a power. But notice something about our power being divided by a power. They do not have the same base, therefore we can't take that shortcut first that says subtract the exponents, because we have m's and we have n's. So instead, we're going to have to just say it means m to the 3rd power over n squared times itself. And we have learned that when you multiply powers that have the same base, we can just add their exponents. So that becomes m to the 6th. And downstairs, we would add the exponents, and we have n to the 4th. Is there anything else we can do? No. So we would say that is our final answer for this one. M's can't be divided by n's. So what's the shortcut for this? What shortcut can we take when we have a quotient, a division problem, being taken to a power? We can take the numerator to that power, and we must also take the denominator to that power. If we go back and look at them, that's what ended up happening. Both the numerator had to be taken to the power, and the denominator had to be taken to the power. So we will just shortcut it so we don't have to write out all of this multiplication. So here we were just exploring what does the property do, what shortcut can we take so that we don't have to show quite as much work. So in number 5, 3/4 to the 3rd power. Instead of taking 3/4 times 3/4 times 3/4, we're just going to get rid of the parentheses by giving the 3 its own power of 3 and the 4 its own power of 3. And then And we do need to show this. And then we will go, okay, what is 3 to the third power? Well, 3 times 3 is 9. 9 times 3 is 27. 4 to the third power means 4 times 4, which is 16, and then times 4 again, which is 64. So our final answer is 27/64. Now, if the fraction back in the beginning, where we started, if this can't be simplified, then we will not be able to simplify the final answer either. You can trust that that will be in simplified form. Okay, let's move on to number 6. We have a negative a over 2. There's our division problem. That's being taken to the 4th power. And these parentheses, they're what show that the whole division problem has to be taken to the 4th power. Well, our numerator is negative, so we have to put it in parentheses because of it being negative and taking it to the 4th power. And then we have to put our denominator, take our denominator to the 4th power, but it's not negative, so we don't have to worry about parentheses around our 2. Well, what happens when you take a negative times a negative times a negative times a negative? In other words, 4 factors that are negative will turn out positive. So we end up with positive a to the 4th over whatever our 2 to the 4th is. 2 to the 4th is 16. So our answer is a to the 4th over 16. Okay, now we have 1/3 being raised to the negative 3 power. So 1/3 is a fraction. It is a division problem. So we will give each the numerator and the denominator that negative 3 power. Now let's do the other shortcut that we have that says, you know what, if you have a negative power on a floor, it can move to the other floor. So if it's up, it can move down. If it's down, it can move up. And then it can become positive. So let's have the 3 come upstairs with a positive 3 power. The 1 move downstairs with a positive 3 power. And we have whatever 3 to the 3rd power is. 3 times 3, 9. 9 times 3, 27. So we have 27 over 1 to the 3rd power. Well, 1 multiplied by itself any number of times will always be 1. And 27 over 1 becomes 27. Okay. Now we have in number 8, x to the 4th power over y to the 5th. That fraction, that division problem is being taken to the negative 1 power. So we're going to give x to the 4th its own negative 1 power. And the reason we use parentheses this time is because we have a power that has to get raised to a power. So those parentheses are important there. And downstairs we have a power again, so we'll put it in parentheses, and then we'll take that to the negative 1 power. Don't try to shortcut this too much. I'm giving you shortcuts to do already. You need to do this step, like we just did here. Now we're going to simplify the numerator and the denominator, applying the power to a power rule. The power to a power rule says we need to multiply the exponents. So it's going to become x to the 4 times negative 1 power. So it's going to become x to the negative 4 power. And downstairs, we have our y to the 5th, a power, being raised to the negative 1 power. So same shortcut, multiply the exponents. 5 times negative 1 is negative 5. Are we done? Is this simplified yet? No, because we have negative exponents. So we're going to apply that shortcut that says, you know what, if we have negative powers within a fraction, have the negative powers move to the other floor and become positive. So the x to the negative 4 will move downstairs and become positive. The y is to a negative power also, so it will move to the other floor and become positive. And now we can say, is there anything else we could do to simplify? Don't have negative exponents anymore. Don't have anything to the 0 power. Y's can't be divided by x's, so we are good to go on that one. Done. Okay. And our very last one here. Remember what I said a little bit earlier? If the fraction can't be simplified in the beginning, then your answer at the end is already going to be simplified. But in this next one, 15 over 10, we can actually simplify that first. We can rename that as 15 and 10 are both divisible by 5. 5 goes into 15 3 times, goes into 10 twice. So we can rename our fraction first of all as 3 halves, and then keep our negative 2 power. And then we will apply our property that says we have a division problem being taken to a power. So we'll give the numerator its own exponent of negative 2. We'll give the denominator its own exponent of negative 2. Then we have negative powers. So we'll have the 3 to the negative 2 power go downstairs and become positive. So we have 3 to the positive 2 power. Downstairs we have the 2 to the negative 2 power, so it's going to move upstairs and become 2 to the positive 2 power. And we can actually go one step further because we can do 2 squared, it is 4. And we can do 3 squared, it is 9. We will get 4 ninths. Now had we done it, kept it just the way it was and worked it, we would have ended up with the same answer in the end. You can just watch me do this, or you can add it onto your papers if you want. So 15 tenths to the negative 2 power. We would have given 15 the negative 2 power, the 10 the negative 2 power. We would have said, well, 10 can move upstairs and become a positive 2 power. 15 can move downstairs and that can become a positive 2 power. We will have 10 squared upstairs, that is 100. We will have 15 squared downstairs, that is 225. And hopefully that is shouting out at you that 25 goes into both of them. 25 goes into 100 4 times. I'll just show that. And then we have to divide the downstairs by 25 also. And how many 25s are in 225? Well, there's 4 in every 100. And we have 200s, so there's 8. And then we get another 25, there's 9. We get the same answer, but we had to do the simplifying in the end because we didn't do it in the beginning. So these are the things you're doing on your homework today. You're finishing up the worksheet. All the problems that you didn't have to do yesterday, you're now doing today. So you will show your work on loose leaf. You will show the steps like I just showed you, and you copied into your notes now to be able to get the credit for having this assignment done tomorrow. Good luck. See you tomorrow.